thank you for coming out today. I know it's really, really hot out there. My name is Coleman, and I'm here today to talk to you guys about Bluetooth Low Energy, and particularly building devices using Arduino. So we're going to talk about a lot of things today. I'm going to fire a lot of information at you. These slides are all online. I'm in full screen mode so you can't see it, but the last slide has a link to the slide, so all the information's online. My goal today is to give you guys enough understanding about Bluetooth to figure out how you guys can implement it in your projects and to give you a chance to answer some questions. If I do this right, there'll be some time for questions at the end, and then afterwards I'll be at one of the Make booths down at the end with some books. You can ask me questions there too. So some of these projects we're going to talk about today are from a Make Bluetooth book that I co-wrote with 2 other people, and basically my goal is to give you some of the basics. We're going to do some really basic things with Bluetooth Low Energy that then if you want to do in your project, you can kind of expand on those building blocks. I'm going to be using, I'm doing things on Mac OS, I'm using Arduinos, but a lot of this stuff will apply to, you can do it on Windows, you can do it on Android, you can do it pretty much across platforms. So first off, what is Bluetooth? Bluetooth is something that we are going to use to connect devices together. We're going to connect them together wirelessly. So you can think of it kind of, the first Bluetooth Classic was essentially like a wire connected between your devices. Bluetooth Classic can do other things like send audio, send a phone book to a car, but if you're using Bluetooth in a Maker project as Bluetooth Classic, you're probably using something called Serial Port Profile. It's basically just a serial cable between the two. When Bluetooth Low Energy boards came out, the first thing they did is they emulated that. They emulated that transmit and receive and just tried to be a wire going back and forth. And that works kind of like Bluetooth Classic. It's a little bit slower, but it really misses the power of Bluetooth Low Energy. With Bluetooth Low Energy, you define a service. So the Arduino that we have is going to offer a service, and my phone is going to go out and find that service and then use that service to control the hardware, or use that service to get information from the hardware. And so that's what we're going to talk about today. We're using a library called ArduinoBLE Peripheral. This is written by Sandeep Mistry, one of my co-authors. It's available in the Arduino IDE if you add a library in there, and it works with a lot of hardware. We first started using it with this Adafruit board. This is a Nordic Semiconductor's 8001 board. It's kind of obsolete, but you can still buy it. It works okay. This Red Bear Labs Shields also uses that same thing. Since we wrote this, there's some new Nordic Semiconductor boards, the NRF51 and NRF52, that do a lot better. If you look at Sandeep's project, he has a compatible hardware list, so it'll help you in choosing which hardware you want to buy. There's also the Arduino 101 board. And I really like this board because it lists for $30. If you live near a micro center, you can get it for $20. So it's pretty cheap. It's got Bluetooth built in. It works with the Arduino tools. It's a good way to get started. There's a library called UART, which pretty much mirrors Sandeep's other libraries. Sandeep works for Arduino, so he wrote this library and he wrote the other library. So they work pretty much interchangeably, even though they have different names. So let's talk about Bluetooth in like a more concrete way. Let's say we want to build a light bulb service, or we want to control a light bulb. Everything in Bluetooth Low Energy uses services. So we'll make a service up, say a light bulb service. And then we need that service to do things, like turn this light bulb on and off. So we have a light switch, and we want to change the brightness, so we have a dimmer setting. So those light switch and dimmer are called characteristics. So a service is just made up of characteristics. When we're writing code for these, we need a way to refer to them. And Bluetooth uses UUIDs, or Universal Unique Identifiers. We're using the 16-bit form, so these are just kind of names that we'll give to the service in the code. We'll call the service FF10, the switch and the dimmer will be FF11 and FF12. So these are hexadecimal numbers. Normally UUIDs are 128 bits, or these really long numbers. We can make these 16-bit ones longer. If you're building your own services, you're supposed to use 128-bit UUIDs, but they don't fit on slides and they really hurt my head to look at them, so I'm using short ones in the slides. So we go back to our service. We have these two characteristics, a switch and a dimmer. We have UUIDs so we can get a reference to them. We also have properties, and the properties control the access. So both of these properties are read and write. For the switch, we'll write a 1 to it to turn it on, or a 0 to turn it off. For the dimmer, we'll write a value between 0 and 255 to it, or 0 and FF if we're doing hex. And that will control how bright it is. 255 or FF is the brightest, and 0 is off. So you can think of it as a kind of like a spreadsheet or maybe even a bulletin board. This service has the shared state. So my phone can look at the state and know what's happening, and the Arduino looks at the state, and they kind of agree. And by manipulating the values in there, stuff happens with the hardware. So when you start doing Arduino or other hardware, you typically start with a hello world, of programming hardware with just a blinking LED. Essentially what we're doing with this service is we're taking the blinking LED and adding Bluetooth to it. So this is fairly straight. We just wire our LED up to pin 6. And then we need to open the Arduino IDE. And so I'm going to go through some of these slides with code on them. And you don't have to get all the details. This is just mostly if you want to go back for reference, you can use these. But to show you, it's fairly straightforward to get this working. If we're using the Red Bear Labs boards or any of the other boards, we'll use, we need to include BLE Peripheral. On this one, since we're using the Arduino 101, we include Curie BLE. So that's just the library at the beginning, we bring that in. We need to create an instance of that, so we just create a variable named BLE Peripheral of type BLE Peripheral. And then we create the service. Remember we had that FF10? We basically make that service, we give it the number, and then we've created a service. We also need to make the characteristics. So I make the characteristics FF11, and that BLE read and write are how I define those properties that were in my table. There's also a descriptor. The descriptor is completely optional. This descriptor is putting the value of switch in there. The reason I do that is when you're using a tool that can introspect these services, it provides like on-the-fly documentation. So I could skip that, but it makes it much easier to use the service if it's documented. And so we create a second characteristic for the dimmer. We set which pin. I'm going to use pin 6 to turn the LED on and off. And then the setup's the only part where it gets a little bit complicated. Right here we're adding all these attributes. I add my service, the characteristic, the descriptor, the characteristic, and the descriptor. The important thing here to remember is the order you add those in is important, and that's due to the way the underlying Bluetooth works. So you add them in the right order. And then this is continued in the setup because it didn't really fit on the slide. The other thing we need to do is we need to set event handlers. Once we write a value from my phone to the Arduino, we want a function to get called. So that's what these two lines are doing here. We're just saying when a write request comes in, call that function. Typically in an Arduino sketch, the loop part of it that's getting called over and over again does tons and tons of work. Here, we don't really do anything. We're mostly basing everything off callbacks, so we just need to say this BLE Peripheral poll, and that gives the Bluetooth radio a chance to do whatever it has to do and listen for messages. So we defined those callbacks earlier. When the switch characteristic is written, it calls into this function. And then we look and we see if there's a value, meaning non-zero, we say digital write LED pin high, means turn the LED on. And if it was a 0, we turn the LED off. And that's all we really need to do. The Bluetooth library underneath takes care of all that communication coming in, and we just get notified when it happens. We do a similar thing for the dimmer. So you'd load all this code up in the Arduino IDE, and you'd choose my board, and you'd load the code on. I saved you from doing all that compiling on my slow laptop, and so now I'm going to demo some of that. So here I have this hardware. This is an Arduino 101 and an LED. And then I'm going to have to do this twice, where I'm going to, I'll show you the hardware first, and then I'll show you the phone. Actually, you know what? Let's do the phone first. So on the phone, I'm going to use a generic Bluetooth app called Light Blue. And so what this does, if I refresh down, it goes out and it scans for everyone's Bluetooth devices. With Bluetooth Classic, you need to pair ahead of time. Here, we just search and we find the devices that we care about. So this one's called LED, so I'll click on the LED. And then so we see that UUID FF10, that's what I called my service. And I see the switch and the dimmer. It has the word switch and dimmer there because I put that into the descriptor. So if I click on the switch, I can write a new value where I can write 01, and then it turns my light on. I'll repeat this with the camera overhead. And then I write a new value and I say 00, and it turns my light off. So if we go to the overhead camera, I'll write a 1 to the switch, maybe. There we go, 1 to the switch to turn it on, and then a 0 to turn it off. So we could toggle it on and off. We could go into the dimmer characteristic and we can write values from 0 to 255 and change the dimming. So that showed that we created a piece of hardware, we were able to connect to it with a phone, completely disconnected there. The problem is if we were building a light switch and I was going to turn that on and off, that would be a pain if I had to go through and do that every time. So one of the nice things we can do is we can create dedicated apps that'll go out and, dedicated apps that'll go out and it'll find the devices that we care about and it'll connect to them. Oops. Hang on, my app crashed. Nothing like a live demo. So we'll try this again here. Let me switch to my backup phone. All right, I guess I'll come back to that demo. If we have, I'm going to need this again. Is it okay if I switch phones? I don't know what I need to do to get this to.
Where are you?
Yeah. Hang on, we'll try one more time and then I'll just pretend that it worked. Oh, I've totally. There we go. This is my old development phone here, and it does not like whatever I'm doing. All right, so that's not working. Hope it'll work on the next one. So anyway, the idea here is you can write an app. We were using PhoneGap for that, and once we have that app, we can then connect to this, and it'll be a lot more convenient. We can also write an app that would be on the computer. We'll go out and scan and connect there. So we were reading and writing characteristics there to be able to control the Bluetooth service. Sometimes when you have a sensor, you want the device to reach out and tell you what's happening. So instead of having to read and poll, which if you do that all the time, that will really kill the battery. So we use something called a notification, where when a value changes, the Arduino will reach out and it'll tell the phone, hey, this value changed. So it's almost like the device is sending you a text message to your code or something like that. So we're going to use a thermometer service for this, and I just made up the BBB0, and I have one characteristic called BBB1, and this has a properties of read and notify, so we can read the value and we can get notified when it changes. You'll notice we don't have write, because it doesn't make any sense that we would write the value of the temperature for this. For the value, we'll get something in degrees centigrade back. So for this, we're using a MCP 9808, which is a sensor I bought from Adafruit. It works really well. I think it costs about $450 or something like that. And I have it wired up to a Arduino Uno with a Red Bear Labs Bluetooth shield on there. And so it takes 4 wires to wire that up. Similarly, in our code, when we create the service, we create the thermometer service, we create a temperature characteristic, and we create a temperature descriptor. One thing to notice here is that before we were sending one value back, we're using a floating point number, so we make a bigger characteristic. And then we have notify. In the loop, we go through here. Normally, in an Arduino sketch, you could put a delay or something in there. You don't want to use a delay with Bluetooth Low Energy, because if you delay, the processor goes to sleep, and then the Bluetooth radio can't. It'll miss messages. So we do this little thing where we have a loop and a variable, and we just check. So this is, we check every 2 seconds. And and then we read the temperature. We basically read the temperature, compare it to our last value, and when we write it to, we set the value, it will notify us. All you have to do is set that characteristic value. If you set the notify property, it reaches out and lets the phone know what's happening. So we'll try to demo this one. I'll switch to the overhead here for a second. There's not many moving parts on this one, so we can plug that in. Here's the temperature sensor, the Bluetooth shield. And then here we have a thermometer app. So when we first connect, you saw there were some question marks. Maybe this working landscape. Okay, I don't know if that was just in the sun. It's hot. I don't think it's 104 degrees though. So there we go. As I touch this, it actually cools down. So it may have just been in the sun and getting really hot. So as I touch that, it changes and the temperature floats and it lets my phone know what's going on there. So the BLE Peripheral library can also create iBeacons, it can create Eddystone beacons, it can act like a human interface device or an HID, being a keyboard and a mouse. Curie BLE can't do all that, so it's really a little hardware dependent there. One of my favorite projects in the book is you can make this lamp that uses colors, kind of like a hue lamp or something. You can control it from your phone. So that's the last demo I'm going to have here. It's an awesome picture that one of my coworkers took. So this here uses the Adafruit NRF 8001 Arduino Uno board and some NeoPixel lights. I'm going to plug this one in here. We have you know what? I think the projector may. I'm going to pass this around anyway. So let's see how this. Wow, not a good day for the demos. Good thing I have a couple phones here. All right. Well. Anyway, I'll keep talking for a minute here. I have an app that, if it will actually connect and do the scanning, you connect to the lights and you get some sliders for the red, green, and blue color components, and then you can slide these on your phone and update the LEDs that are on there. And that currently isn't working, but I'll work on that while I'm taking some questions. So, here's a picture of the UI if I get this working. And here's my information. If you guys have questions, you can reach out. The slides are online. All the code is online. And now I'd like to take a few questions. And while I'm answering questions, I want to get this demo working and so people can see that. Questions?
Boards that you're using, the breakout boards.
Okay, the question is, what is the name of the breakout boards that I was using? So this first one with the LED was an Arduino 101, made by Arduino. This one right here is a Red Bear Labs Bluetooth shield, and the Maker Shed used to sell that. And then this one here is the Adafruit NRF 8001. Yes, red shirt.
What about, so I'm just wondering, do we need to be concerned about security, like if we're going to make a light and then we can just write to a variable through Bluetooth?
Yeah, so the question is, you need to be concerned. Yeah, one of the weaknesses in Bluetooth Low Energy is the security model isn't really that good. The data between the light and the phone is encrypted, but there's nothing really stopping you from connecting to my light and controlling it. There's a process called bonding, which isn't really used as much. That's one way you can do it. You can bond your phone with the hardware. A lot of the Arduino hardware doesn't support bonding as well as I'd like. You in the white shirt?
In production, obviously, our users aren't going to be using that free Bluetooth app to connect to things. They're going to use an app or a web app.
Yep.
How do we get there?
So, one way you can do it, I mean, iPhone and Android both have supported Bluetooth Low Energy for a while, so that's good. If you're using Mac, Linux, Chrome OS, or Android, you can use Web Bluetooth to connect to it, where you actually have a web page that controls that controls the device. If you're using
I didn't know about that. That's cool.
yeah, and if you're using anything that runs JavaScript, you can use Node.js. There's a lot of good stuff there. In the back?
You kind of mentioned in the passing that you're developing dedicated apps using PhoneGap. So is that something that's covered in your book as to how to go about developing apps using PhoneGap that would sort of connect with one particular Bluetooth hardware or service?
Yeah, so the question is, I mentioned PhoneGap and developing it. One of the there's a PhoneGap plugin. PhoneGap lets you write phone apps in JavaScript and HTML, and I've written a PhoneGap plugin to do Bluetooth. We use that in the book. We use a way that even if you have a Windows computer and an iPhone, you can do that in the book just for learning, but not necessarily for production. So. All right, I finally got my lights going here. It took I don't know what it was connected. So as there's 3 sliders on this user interface. If you move them around, you can control the color of the lights. So feel free to control those lights up here and pass that around. Yes?
Yes, you've described phone communication very well. What about processor-to-processor communication with BLE? Between, say, 2 Arduinos.
Yeah, so the question is, can we go between 2 Arduinos with Bluetooth Low Energy? Until recently, no, you couldn't. The Arduino was acting as a peripheral, or like the server part of it, and the phone was the central role. So the Arduino 101 recently had an update to the libraries where it can be a central role, where it could go out and connect to another device. So the chips that are in here are the older Nordic chips, so they don't work as well. The newer ones are a lot more full featured, so they can act as both a central and a peripheral. So you could have 2 devices connect to each other. Anyone else? All right, and then I've been told by the Make people that way down at the end of that road, past the food trucks, there's they're selling magazine subscriptions and stuff like that. Supposedly they have some books down there. I'll be down there for about a half an hour talking to people, answering questions if you want to get a book signed. No pressure to buy a book, but it's nice if you do. So anyway, thank you very much.